hear me okay? My name is Kevin Lynagh. I'm going to be talking about building visual interfaces on the web using Clojure and ClojureScript. So the agenda for the talk is in 3 parts. The first part of the talk, I want to talk about why quickly. So why use visualizations, and then once you've decided to do that, why do it on the web, and then especially, why use something like Clojure and ClojureScript over the more traditional JavaScript. And then I want to make that a little more concrete by walking you guys through an example. And then finally, I want to discuss some of the higher points, which will sort of come clear in the example where the real main thesis for this talk is that you should treat your view as much as possible like data. So not treating your view as this kind of like a box. So don't treat the browser as just this screen that you're banging against and mutating state on, but as much as possible, treating the view as just another kind of data, which lets you really use all of the functional power that you're used to, so using pure functions and stuff like that. And then, as part of a quick agenda or note, I want to point out that this isn't really a tech talk, so I'm going to talk a little bit about Clojure, I'm going to show you some code and stuff like that. But it's more of a talk of this sort of broader idea. So if you don't grasp like the particulars of the Clojure syntax or something like that, don't sweat it. And I hope you can take some of these ideas and use it in your own work on whatever language that might be in. All right, and so like I said, I have a 25-minute slot, so I'm going to speak for about 20 minutes, and then I'll leave 5 minutes for questions at the end. But I will be in Copenhagen until Tuesday, so if you do want to talk about technical particulars, drop me a line, we can drink beer and get lost or something. All right, so part 1, why visualization, why on the web, why with ClojureScript? Some people have kind of mentioned some of the broader trends before, but really I found, so I run a small consultancy in Portland, and we work with more technical and scientific clients to make these sort of web-based visualizations. And what I found is that there isn't a lot of problems having data. Like a lot of people have lots of data, and all this stuff is out there, but the problem is that it's in some database or it's in log files or something, so it's not really like accessible, right? So what we found is that it actually goes a really long way to make some even very simple visualizations that let non-technical people access this data and actually get some sort of understanding from it, and be able to make decisions using that data. So as an example, this is a little video of a bioinformatics application that we just finished up with some people at the Harvard School of Public Health. And you guys all heard about this biology stuff already, but the idea is that sequencing is getting cheaper and cheaper and cheaper, and so biologists are getting all of this data, but it's not natural for them to just open up a terminal and start banging out a Perl script or something to analyze their data. And so to be able to use something like modern browsers and let them just like upload their data and then like sub-select on things is actually really powerful. So this isn't really fancy algorithmic stuff or anything, but we're taking just simple things like filtering and making it accessible to more people so they can use it in their research and stuff like that. And this is all written in Clojure. This is actually an open source project. It's all very new, but it's on the GitHub if you want to dig it up. And it's actually something like 700 or 800 lines of code, which is pretty sweet given what it does. Another example, this is a project, I'll talk more about this later. This is a screenshot of a dashboard that we made for the iPad. It's for a client that runs wind farms, right? So they already had all this infrastructure, but they had all this information about the wind turbines, like how fast the wind is blowing, like the temperature of the gearbox, and like the oil levels and all this stuff. Like they had all of this in some huge database, but it doesn't really do any good if it's just in this database. Like what they really needed was to have it in the field, like literally in the field. Like people are driving around in jeeps, like the mechanics who are taking care of these wind turbines, and so be able to take some of this data and present it to them. So in this screenshot, right, it's just some simple bullet charts. But to take some of these numbers and sort of give them the context to be able to say, they can look down and very quickly see that, like the oil level of turbine 17 is like now getting low, we better drive over there and fix it. Ends up being really powerful and really useful. So those are some of the reasons you might want to actually use visualization to sort of make data more accessible or make it more actionable. So once you decide to do that, why target something like the web? There are 2 reasons that I find very sort of useful to think about. One of them is just the feature set of the web. So modern browsers have gotten really, really nice. Baked into them you have things like vector graphics, You have stuff like CSS, so this declarative styling language is really nice. You have a scene graph already built for you. You don't have to roll your own. And then also, maybe the biggest advantage is you have all of this awesome tooling and community, right? So stuff on the web happens really fast. There are tons of people out there who are making new libraries, new tools, and stuff like that. And so if you're building applications on the web, you can take advantage of a lot of that stuff. And so it's really nice as a developer to have all of those things. And the other big advantage of doing stuff on the web is that you get this reach, right? So if you build an application using something like HTML5, it's going to run in like Google Chrome on Windows, on Mac, on Linux or Unix or whatever, and then also on some of these mobile devices. So you can use the same kind of web stack and target something like the iPhone or the iPad and get pretty good experiences for people. And so that's really powerful to be able to kind of use all of that stuff that you're familiar with and have the reach on all these different kinds of devices. Unfortunately, if you do stuff on the web, you have to use JavaScript. So you guys, most of you are probably familiar with JavaScript. It's definitely not the worst language out there, but it does have a lot of kind of odd quirks. And the issue is that, the advantage of JavaScript is that it's everywhere. It's in all of these devices. It's all over the web. But the disadvantage is that because of that, we can't really update it. So there are these kind of strange quirks, and we can't push out a new language version because then we would lose this advantage of having it everywhere. So that's no good. And so what people have been doing is actually treating JavaScript as a compiled target. So to say, okay, look, we have basically this VM that's everywhere and all these things. Why don't we take a higher level language and then compile that language down into JavaScript and kind of treat JavaScript like machine code or something. And so the one project that I'm familiar with that's doing that is Clojure, which was released about a year ago, just over a year ago, by the Clojure core team. It's a project that compiles Clojure into JavaScript. Clojure is a Lisp for the JVM. It's about 5 or 6 years old now. And compared to JavaScript, it's really nice because it's got much nicer data structures than JavaScript. And it even has kind of like little things. So like namespaces isn't like the sexiest thing in the world. But if you use JavaScript, you basically have to roll your own namespace system anytime you want to build a large application. And that gets real old real fast. So it's really nice to be able to use something like Clojure and kind of have all this stuff built into the language and just be able to take advantage of it. And the other thing too is that you get this sort of nice consistency. So I don't know if you guys have seen these sort of like videos on the internet, like JavaScript what, where it's basically there are all these quirks and surprises and strange things in the language, and it's nice to not have to worry about them by having a sort of higher level or more modern language. But really the biggest advantage of using Clojure is that you get this philosophy. You get this Clojure philosophy, which is really the philosophy of a lot of functional programming in general. And there are a lot of different things in here, but for me, the biggest has really been how you think about state. So in Clojure, everything is immutable by default. So you're not taking objects or arrays and just like banging on them. You're not adding new stuff to a map. What you do, right, is you call some function and you get the old map with new keys in it, but it's a whole separate thing, right? So stuff is immutable by default, and what that means is that when you kind of sit down and kind of think about when you're building applications, it really forces you to confront this issue and ask yourself this question, in this application that I'm building, what is the essential state of this application? Like what's core in here, and like what do I need to think about and focus on when I'm building this thing? So that's all a little high level, so I want to bring it back down to earth with an example here, and the example that I want to give is from this wind power dashboard that I showed you. So I'm going to kind of walk you through quickly building the actual map part of it. So what we have here is we just have kind of a static terrain map, and then on top of that we have these little icons for the actual wind turbines. And so in the live dashboard, these things kind of spin around based on the wind direction, and they're also animated, so you can see when the wind is blowing quickly, or you can see the blades moving fast and stuff like this. So if you're going to make this application, kind of sit back and think, like, what is the core sort of immutable state in this application? What's the essential state when you're building something like this? Right, and that state is just going to be the state of the park, right? I mean, it's the state of all these turbines, and so if you actually kind of sit down, you can represent it in Clojure code here. And again, like, don't worry about any of the syntax or stuff like that, but really the core idea is that the essential state for this map is just all of the turbines. So we have basically a collection of maps, and those maps have Each map represents a turbine, and they have keys like the latitude and longitude of the turbine, and the wind speed and direction at some point in time, right? And so the name of the game when we're building this application is to say, okay, we have this abstract domain data, and we want to map it to something on the screen, to some image on the screen, to this dashboard. And this isn't going to be a huge surprise for you guys, but the kind of argument that I like to make is that what better way to take data and transform it into another kind of data than to use just pure functions, right? Like this is what they're for. So the idea here is to just use pure functions, and to do that, just treat your view as just another kind of data. So I don't know how many of you are familiar with things like HTML and SVG. Basically, it's kind of like this tree-like data structure where you have like elements and tags and things like that. And this is an example of a kind of casual notation used in the Clojure community called hiccup, which is a way to represent HTML using just vector literals and maps. So you can see here, this is a single vector, and the first element is like a keyword. So it says like this is an HTML div, and it's going to have a map of attributes, and then everything else after that is children. So it's got this paragraph child with some text children and another tag and stuff like that. And so you can treat your views as data this way. And if you do that, right, your templates for your views are really just pure functions, okay? So this is a function that you use to make the markup needed to render one of these turbines on the map. And so I guess let's walk you through real quick. So we're defining this function called spinner, and then it takes one of these maps that I showed you earlier, and we know that it's a map, and we know that it has certain keys. So Clojure has some nice destructuring functionality or syntax. So those are the next two lines in the let. We're basically saying take these keys and make them into local variables. And then the return value of this function is going to be one of these hiccup data structures that just represents the markup that we want. So we want to have each turbine be represented by a div that has certain classes and has some certain CSS styles on there. And what's cool about doing this is that you're just working with data the whole time. So to bring your attention to these CSS styles, right, this is just a map, right? And you can abstract things as necessary and sort of as it feels right using pure functions. So you can see in this case, we have the latitude and longitude in this style map to actually position it on the screen, because the browser doesn't understand latitude and longitude. We actually have to convert it into a percentage width or something like that. But that kind of functionality is not specific to turbines. So if we have other stuff on the map, we might want to reuse this functionality. And it's very easy to do that because you can just kind of factor it out using functions. So you can just define a position function that takes anything that has a latitude and longitude, and you can merge that back in. And so that's pretty nice, right? Because you can just break these things apart and compose it and do programming. So to step back, right, we have this function here that takes abstract domain data and then transforms it, so it's a pure function, transforms it into another piece of data representing the markup that we actually want on the screen. And of course, it's just data still. We haven't actually rendered it, so to actually draw it on the screen, we have to eventually call some side-effecting function. Here we have a function just called render bang. That's not any particular piece of Clojure semantics there. It's just sort of conventional to use a bang, your side-effecting function. And you can just compose these other things, right? So our function just takes a single turbine and returns the markup for that single turbine. If you want to do it for all the turbines in the park, we can just map that function over our collection. So give us something like this, and then you actually call render, and it actually draws it onto the screen. So here's a little workflow for that, right? You have the domain data, you use whatever sort of functional programming you want to make this huge function that takes that domain data, maps it into the markup that you want, you call this render function, and then you get your stuff on the screen. So that's not maybe like particularly interesting or fascinating. You can do this stuff with JavaScript templates or whatever. But where the real advantage comes in, or one of the real advantages of treating your markup as just another kind of data, comes in when you need to do updates, right? So if you get some new domain data, you can run it through the same function, get some new markup, but you can't just render it to the screen again because all your old stuff is still there. And you don't want to just throw it away because aside from being kind of expensive to be throwing away the entire DOM tree and rebuilding it every 2 seconds, it also rules out things like CSS animations. What you really want to do is you want to merge. So you basically say, this is what I want on the DOM, and then you want to be able to merge that into what exists on the DOM. at that point in time. So for instance here, on the top we have the data structure representing the markup that we want, and then below we have what actually exists on the DOM. And both of these things are still data. So both of these things are just like trees. And so you can actually use like a library function to just walk this tree and sync things up. So, you can say, oh, we need to have a div that has this ID, and it's like, oh, that already exists on the browser, great. And then you can recurse and go through and say, okay, well, we need the first child to be this div that has this class and these style properties, and then, update stuff in place that way, adding and removing elements as necessary. And what's cool is that, this is something that you only have to write once, or I wrote once, and now you don't have to write it all because it's a library function that works totally generally. So that's pretty cool. But we can do even better than this, because if you notice here, we would still have to call some merging function when our data changes. And ideally what you want is you want something like data binding, right? Like you want to be able to have nice semantics around mutable state, and to be able to add watchers and have stuff sort of automatically propagate through when that state changes. And that's not something you can do with plain JavaScript, but Clojure has these sort of nicer semantics around mutable state, so you can do that. So here's a function just called bind, and it's basically we're saying, here's this piece of mutable state. Whenever that state changes, I'm going to automatically rerun these sort of rendering functions, merge that into the DOM, and then when you do that, you can actually get a cool little video. And so here, this is just a screenshot from the actual dashboard. You can see every second or whatever the information is getting updated, and the DOM is getting updated, and then they're actually like rotating up and down. That's from CSS animations and stuff. So in modern browsers, you can just say when these attributes change, I want you to animate back and forth, and so you get sort of all that stuff for free, which is really nice. So if you're interested in this stuff, there's a library called C2. So this is all open source. It's on the GitHub, and you can check it out and kind of see more examples there. And then, so for the final part of my talk, I want to kind of expand on some of the points here about what you get when you treat your view as just another piece of data. So I've kind of shown you, hopefully, some of the advantages or things from that approach. I also want to talk, of course, about some of the trade-offs. The first one is going to be a trade-off that you always hear about with functional programming, which is performance. And here, right, if you're walking the DOM, you're comparing data structures, it's always going to be a little slower than if you have a direct reference and you're just kind of banging something in place. But the answer is, for this question, the same as in general with functional programming. You say, well, let's benchmark it and see when does it matter, how much does it actually matter. And in our case, the kind of stuff that we're building, we found, maybe it costs 40 milliseconds here or there, but the advantages that we get out of using pure functions and kind of this approach definitely outweighs that kind of negligible performance difference. The other big trade-off here is that you're coupling your markup in your application code quite a bit. So I know some shops, the designers and developers never talk to each other, and they just kind of throw CSS selectors at each other back and forth. You can't really do that with this approach because the application developers have to be able to kind of mess with the markup because it's in the code. At Cheming Labs, it's not a really huge problem because all the designers are pretty friendly with the tech stuff, but at some bigger shops, maybe it's an issue. So that's something to keep in mind. But I think the advantages for a lot of cases really do kind of outweigh these trade-offs. And most of those advantages here come from this sort of decoupling, right? Because you're decoupling the specification of what you want from the actual rendering of that thing. And so that means that when you're writing this code, you get a couple cool things for free. One is you get runtime flexibility. So Clojure was originally written for the JVM. There's an implementation of the CLR. Clojure script is what I just mentioned, is a Clojure compiled to JavaScript. There are also some community projects to compile Clojure to Lua and C and Objective-C and stuff like that. But it's kind of cool to have this flexibility. So we've had projects where some stuff we do is it's actually running in the browser. It gets compiled to JavaScript and runs in there. But we've had other projects where the client just wanted like a jar file and they wanted to run it on a JVM. And we could use a lot of the exact same code in between like those two kinds of projects, which is really powerful. And also with this runtime flexibility, you get very easy testing, right? Because you don't actually need a browser a lot of the time. If most of your application code and sort of domain-specific code is just pure Clojure code, it's very easy to do things like unit tests because you're not hitting some DOM. You don't have to worry about getting some fake browser or fake DOM implementation to do your tests. You just say, look, these are pure functions. I'm giving it this domain data, and I want this kind of markup data out of it. But you can just write those tests very easily, so that's pretty cool. And ultimately, you end up with just less code, which is always a big plus, right? You're writing most of this stuff in the forward direction. You're saying, here's my data, and then this is like kind of all the mappings that I want. I'm going to make them very explicit with pure functions, and this is the output that ultimately I get. And so you're just always working in this one direction, and you don't have to worry about kind of juggling the application state in your head as you're doing stuff. So say, I got new data, oh, that means I have to update this, and update this, and update this. You just say, here's the mapping, and then let's just merge that into the DOM of this low-level library and take care of updating all the individual elements. And so because of that, right, you get much fewer DOM references that you have to juggle around, and just data flow is much clearer. So this has kind of been an approach that we've been experimenting with and playing around with for the past year. It's been working out really well, but I don't know that many other people who've been doing this thing, especially on the web. JavaScript programmers have lots of opinions and lots of MVC frameworks, but I don't know how many people have kind of tried the sort of more out there functional stuff. So I'd definitely be interested in talking with some of you guys about that kind of thing and what your experiences have been. So thanks.